Our next speaker is Dana Porter. She's an agricultural engineering specialist in agricultural water management at the Texas A&M AgriLife Extension in Lubbock. Excited to have her here joining us today. She's going to be talking about what agriculture can do to save water. Something that, obviously not only do we need to look for new supplies, but we need to stretch the resource further. So let's give a warm welcome to Dr. Porter.
Thank you. I guess it's great to get to see friends and contacts, and just it's really great to be here. I appreciate the opportunity. The title I was given, More with Less, What Agriculture Can Do to Save Water. And a lot of these things you already know. Some of you know better than I do, and I'm sure that you'll correct me. But I do appreciate this. I think there are tremendous opportunities in agricultural water conservation. Obviously, it's part of the regional water planning process, and in your regional water plans, we talk about these. Just a little perspective, again, preaching to the choir, but agricultural water use in Texas, the blue boxes. This is from a publication by Kevin Wagner. It's a few years old, but looking at the water use sectors in different regions in Texas, agriculture comprises about 95% of the groundwater withdrawals. In the region O, that's where I'm based. I'm from Lubbock, Texas. So we use a lot of water there. So water conservation can actually make a big difference. It is important to us, obviously, and a lot of you guys. Also, a little perspective. Again, my bias from region O. Total area and crop production, we're only about 9% in the state. But as far as the total irrigated acre, we're 46%, about half of the total, almost half of the total irrigated acres in the state. So we can use a lot of water, but we have we've made some really great progress in we give the credit where it's due. The producers have adopted the technologies, and they're doing the management to make it work. In the National Agricultural Statistics Survey, Census of Agriculture, there was the 2018 survey looking at barriers to adoption of water conservation and energy conservation practices in Texas. If you can see, you can look at, a lot of these are related to capital investments, economics, will it pay, return on investment. A lot of them, can I get the money? Is it gonna pay? We'll get into these a little bit more in depth. And then a few of these things, is it gonna work practically? So these are the concerns that the producers or landowners will have on whether they're gonna adopt technologies. And I'm gonna dig through these a little bit more. A lot of you, especially from the rural districts, you know a lot of these things, but I try to present it in a way that just to try to explain the complexities of the decisions. It's not, I think I work in the irrigation applied research world and extension world. I work a lot with producers, more agribusiness, those audiences, but sometimes people will say, researchers will say, well, why don't the producers just adopt my technology? Well, it's more complicated than you think it is. There are a lot of things that go into those decisions, and so let's just kind of scan through some of these. I said economics, that's in the surveys, that's what the producers are saying, why they may be reluctant to adopt some technologies. First of all, they look at the cost benefits. Okay, is the technology going to pay for itself? Can I afford? Can I get cost share assistance? Can I get a low interest loan? And I know that a lot of the groundwater conservation districts facilitate these adoptions through programs that you have, and those are really appreciated. I do dig into your websites, and I appreciate what you're doing to promote water conservation in agriculture. And hopefully we'll have also the promise, if I manage my water better, if I get a better return on the water I put out, hopefully I can get the same or better yields for lower inputs. So those are the things that we look at in research and extension, and I know that you also promote them, and I really appreciate that. We look at climate and crop considerations. Okay, it's not a one-size-fits-all for technologies. So I look at the soil texture. It's going to make a big difference if I have the water. If I'm basing on soil water monitoring, it's easier with a Pullman clay loam than it is for a brownfield sand. You know, that soil texture is going to make a big difference. The drought tolerance of my crops, we'll dig into this a little bit more. Integrated pest management, there are a whole lot more decisions about climate and crop considerations that, again, it's not a one-size-fits-all. What practices are going to work? I look at the effectiveness of strategies. Will the strategies work? Now, okay, let's say adopting micro-irrigation. Micro-irrigation is a great tool. It doesn't fit for every operation, and it's not a good fit for some management considerations. I will say that if I don't have access to three-phase irrigation, three-phase power, I may have a harder time with my center pivots, okay? So again, they're just these practical considerations that a lot of people may not fully understand. And of course, some of us on the inside know that there are some heavily marketed strategies and technologies that may not deliver what they promise. And we need to be realistic in what we consider and what we advocate. Technology consideration, again, the power availability. We have some new advanced technologies, and I'm working in some advanced irrigation controllers, automation of technologies, automation of irrigation, and some of the graduate students we're working with, electrical and computer engineers, we have to explain to them why some of this stuff has to be able to work off the grid. Everything is going Internet of Things, and that is cool, and I like working with it because I can grab the data, automate the control, run a little machine learning, optimize my irrigation, and tell it to irrigate. But what if I don't have good internet connectivity? It's going to be a different process. Or what if I have privacy concerns with my data? So there's some other concerns there, those technology and privacy concerns. Policy considerations, crop insurance, that's a big one. When I was an absentee landowner, I went to my crop insurance guy before I made any changes, because am I going to be covered? If I change this practice, if I change this crop, am I going to be covered? And that was a very important thing. Of course, the water regulatory. I was in C.E. Williams district. So, okay, CE, how much water can I use? And what's the pumping limits? And so I take those into consideration as well. And then the operation-specific considerations. And this goes all over the place. Labor and management ability. So I know a landowner, he actually has property in New Mexico. He had everything fully automated on his drip irrigation system, and he went back to manual valve control. Why was that? Well, because his irrigation manager couldn't run the programs for the automated controller, but he could turn on and off the valves. So that made a big difference on what he could use. Landowner and tenant preferences, field layout, crops, there's so many different operation-specific considerations in adoption of those technologies, and whether or not they're going to work, whether or not they're going to pay, and how effective they're really going to be. So I don't think I'm telling you anything you don't already know on this, and I encourage you to add to the list. But it is complex, the decisions are complex, and sometimes the farmer is not the only one making those decisions. A lot of times it is the landowner, it might be the crop insurance. There are a lot of those considered, a lot of voices in his head. There was a gentleman that used to call me when I was a news specialist. He'd call me and just ask me hard questions, one after the other, and I thought he was picking on me. And a few years into this, he called, and we had a really great conversation, and I turned after, answered his question. Really what it ended up is he would ask me a question, I'd ask him a question back, and really unbeknownst to me, what I was really doing is helping him think through his decisions, because he trusted me, I was objective, and I was the only one he would talk to that didn't have a dog in the hunt. I didn't have a financial stake in his operation, and he would just ask me questions and talk it through, and that's how he worked it out, but because it was complex. Some agricultural water conservation strategies that we have, again, my bias in the High Plains. High Plains agricultural producers have really been rapid adopters of advanced irrigation technologies, including the variations on the theme of low-pressure center pivot irrigation, where it requires lower energy compared to the higher pressure systems, and we can achieve higher efficiencies with those systems. And you've heard of LEPA, or low energy precision application, low elevation spray application. mid-elevation spray application, all these variations on the theme, but we can achieve some very high application efficiencies, very high uniformities with good management with these systems. We also have a relatively high adoption, particularly in the South Plains, about a 9-county area around Lubbock, of subsurface drip irrigation, micro-irrigation in general, but where the water is more limited capacity, where the in our soils that we have, in our crops we have, particularly cotton, we've had some very good successes with micro-irrigation, subsurface drip irrigation, and more recently, the wine grape production uses micro-irrigation, so we've had some really good successes there. It jumps ahead, sorry. Some further improvements of efficiency. When I interviewed for my job that I have now, I interviewed more years ago than I dare admit. Too many people, too many of you guys know me too well. You know how long I've been there. But I was asked the question, okay, we have subsurface drip irrigation. We have LIPA irrigation. What's the next big technology? That was the question I was asked. And the best answer I could come up with at the time was, we have the tools. The producers are using the tools. But we can definitely improve how we're managing and using those to get the difference. Because I see these, you've all seen the numbers, this irrigation system gets 95% efficiency. That one gets 98% efficiency. I hate that because it's not true. Those are achievable efficiencies, but I can manage it badly and get very bad efficiency. Steve's nodding, goes, preach it, sister. So I need to manage it well. And there are a lot of things I can do to improve that management, and that's really what I've dedicated my research to, irrigation scheduling tools. Okay, now I need to understand the information that goes into that, and we'll get into that. I depend on locally relevant research programs that address local issues, locally relevant, local conditions, local crops. People trust that, and they're applicable. It also depends heavily on collaboration between university research, extension, industry, the groundwater conservation districts in the High Plains and elsewhere, but I'm biased. Okay, I'm in the High Plains. Tremendously supportive of applied research programs to help us improve, to help us do a better job, and we really appreciate that. A USDA Agricultural Research Service, these guys are smart. They're doing some really great work, and it's really great. These partnerships are helping us a lot. So working together and working with the producers, we're getting some answers that they need. Waiting for, okay, there. What I've been working on, and there are some major manufacturers of irrigation equipment and some public sector and third-party private sector groups are offering packages to monitor and control irrigation equipment. So you have automated center pivot irrigation, automated drip irrigation, and that can be anything from a simple timer like you have on your lawn irrigation system to advanced machine learning-based control technologies, which are way fun to work on and challenging at the same time. A lot of the companies are offering internet-based dashboard visualization, so I can pull up my phone, I can tell where my pivots are running, I control them, I know how much water, it helps with the record keeping. These are some very good tools. Variable rate irrigation capabilities, programmable controllers, and sensor-based technologies are really advancing the capabilities, and what we're doing then is we've got a lot of data. Well, now the producer's got a lot of data to deal with. So now we come up with decision tools to help him manage that, so to help process that data. Regardless of the tool selection, I'm going to have to manage and maintain the irrigation system. Again, with Steve's permission, I'll just repeat it. I can take a really good system, manage it badly, and get bad results. If I manage a surface water irrigation, a furrow irrigation, I grew up moving gated pipe, by the way. If I have a well-managed, well-laid-out system, I can make some really good improvements into that. I can do a good job with row water if I really pay attention. It's easier to do that with a center pivot system or a drip system. But managing it with the knowledge, there's a lot of research, a lot of good information and knowledge that we have about crop water requirements, soil water holding, sensors, that we have a lot of information available, let's use it. And let's help, I think if we can get integrated and communicating, get integrated with our messaging, we can help our producers do a better job and use the data that they have accessible to them. And managing the total water in the context, because if my crop has a major disease problem, dumping more water on it's not going to fix the problem. So I need to manage it in context of the total crop. So I'll just kind of venture out into your territory a little bit more. Regional water plans include conservation strategies to help meet the water needs. And I'll pick on the Region A group. I really appreciate what they've done with the agricultural water conservation strategies. They've been fairly consistent over time, and they've evolved over time, doing a tremendous job. And we'll step through these: irrigation scheduling, equipment changes. All of these are listed in their regional plan. Hopefully you've read the whole thing, all however many thousands of pages that it is. Let's go. Irrigation scheduling. Okay, let's pick on a lot of these. How are they going to help conserve water? What are some of the pros and cons? Irrigation scheduling, first of all, what it is, it's applying the information, the knowledge that we have from research and experience, local in-field data, so I may have soil water monitoring, I may have local weather information, and I'm going to use this information I have to guide irrigation timing and rate. And the timing of irrigation is going to be based on the crop water requirements. Now I start finessing it. A lot of the research now in the Lubbock area where we're supplemental irrigation is what we call, we don't like to say deficit irrigation, we call it supplemental. In other words, we're going to maximize the rainfall as much as we can, and then we're going to see what we can do, how much we can do with a little bit of, with the little water that we have. So we're going to time it. When is it best? So Jim Brodowski did some tremendous work on, if I have to short cotton, when can I get by with shorting the water on the cotton? So maybe early it doesn't use that much water. At peak bloom, I really need to give it the water, and then I can back off. Okay, and other crops. So we look at those sensitive times, and we start getting into the biology of the plant, the soil physics. We've got to put these pieces together to be able to do that well, because when you start really tightening your water applied, your risk goes up of missing the mark. The water-saving opportunities with irrigation scheduling are irrigation, particularly initiation and termination. So at the beginning of the season, when do I need to start it? And as the crop gets near maturity, when can I stop irrigation? Those are some good opportunities where I can cut an irrigation application or two and save an inch or two of water in one season on one crop. And I do this over several 100,000 acres, and it adds up. The other thing is I need confidence in the numbers. So I see the numbers. I've got a soil probe in there. It's given me a number. Should I trust it? Can I trust it? And so the work and working with the producers, again, with the work that the groundwater districts are supporting and the work that you're doing with producers, this is really helping those producers understand those numbers and decide whether they can trust the numbers. Irrigation equipment changes. This is a big one in the high plains. A lot of people have already adopted the low pressure center pivots and the drip irrigation. And so a lot of those have already been made. We've reduced the evaporation and runoff losses. The cost of that, the disadvantage is capital investment and the management, the change of management. So I really have to learn how to do it. The benefits: improved precision, improved application efficiency, and uniformity. The catch is it still needs to be managed well. Soil management. Okay, we can spend days on this as well, but it goes anywhere from land forming, land leveling, furrow diking, contour tillage. Those things are tried and true methods. Now we're starting to talk more about soil health. What is it really? What the value is it really? And we have to manage it. There's some good research going on right now looking at, particularly in the more arid or the lower rainfall areas, the lower water quantity, capacity areas. What are the crop mixes that are going to make sense? Because Jordan Bell's doing tremendous work. I figure Steve will correct me. Steve or somebody will correct me, but they're doing some really good numbers. Right now, I think the jury's still out. In some places, the cover crops are really doing some beneficial work. On some areas, we may need to adjust the crop mixes and the recommendations for more local conditions to make sure it works. Also, there are some, again, practices that are well documented. There's some other practices and technologies that are promoting some unrealistic claims, and I think we need numbers and we need to be realistic about what we're achieving with those, and there's some tremendous opportunities ahead. Advances in plant breeding and changes to crop varieties. There's several breeding programs in the state that are working on drought tolerance as traits, as well as salt tolerance in traits. Jane Deaver's group has a salt tolerance in cotton, for instance, that came up earlier today. These drought-tolerant crops they may or may not be less water demanding. They can get through the drought times better than those that are not drought-tolerant. The peak water use, though, is about the same. And so I look at the crop water curve, I can get by with less water, but it doesn't mean the crop necessarily uses less water. It may or may not. Now, where I can conserve water is the shorter season. So my peak water use or my the daily demand might be the same as the full season crop, but I'm shortening. I'm condensing that growth curve. I'm shortening the time frame, so there are fewer days to irrigate. So that's where the opportunity to save water is. But it also means if I miss that irrigation window, the error has a bigger impact. So I need to be better at managing it. So we're working with the breeders to come up with the management plan that goes along, the recipe that goes with the ingredients in the box. I need to follow the recipe to make it work the best. Also, with the shorter seasons, I have some opportunity to plant, to try to adjust my earlier or later, my planting window to miss the peak water time. You know, in the high plains, that late June, we typically end up with a real hot, dry spell right in that last week of June. If I can get it where my corn is tasseling after that, that's good. That's good. Other strategies: conservation to dryland farming are addressed in the water plan, and changes in crop type. There are special risks. Of course, if I stop irrigating, I'm going to save water. But there's some risks involved. You know, if we talk to our growers, and I've heard researchers just say, why don't they just convert to dryland? Okay. So how about you run your sandwich shop without bread? You know, you can still sell meat and tomato slices, but, you know. There's some risk associated with that. Supplemental or deficit irrigation I talked about earlier. We need to manage it carefully. You know, if I miss the mark, if I'm just applying limited water at critical times, I better know where that critical time is, and I need to know when I need to have the water there. So it's a little more risky, a lot more risky. Another thing I can do is irrigate smaller, like a lot of the producers in the South Plains irrigate smaller acreages of higher value crops, wine grapes, for instance. And I'll go back to my sweet corn breeder. Wenwei Shu has some corn varieties that are drought tolerant, heat tolerant, fumonisin resistant, meaning I'm less likely to grow the crop to the end of the season and get it totally rejected and unmarketable. So I'm more likely to make a marketable crop with less water, and it's got some higher nutritional content. So it's got some niche market, and it's some wild colors too. So I could, you know, he's looking at selling it for a higher value. So maybe that's an alternative to the wine grapes, and it doesn't require me to buy special equipment. I've already got the combine. I can already harvest it. So those capital investments is another risk that we took at. I said, well, just grow a niche crop. Well, that's great. How am I going to plant it? How am I going to harvest it? How do I store it? Where's the buying point? So those are some considerations. I'm ending a little early because I encourage questions. I know that's a dangerous thing to do. But I want to take a little bit of time to acknowledge the support that the research that I do, and I don't do it in a vacuum. I work with some tremendously smart, wonderful people. USDA Agricultural Research Service at Bushland, Texas in particular. Calvin, I work with Thomas Marek, research engineer up there, who's just, if y'all know him, he's smart, and there's nothing he can't do. His son Gary is a research scientist at ARS, and he's doing some tremendous work in modeling, remote sensing, scintillometry, which I cannot spell, but no. Looking at real measurements of evapotranspiration demand, atmospheric demand, really digging into the long-term data that they have collected on the weighing lysimeter. So he's really drilling down into the true water demand of the crops and water efficiency. And so he's advancing. He's working with some other smart people. He's great. Jordan Bell, tremendous agronomist. So I could go on and on, but what good am I? I know smart people. That's my connection, as I know smart people. But we do have good, the water seed program at Texas A&M University has really helped with this research that we're doing. The High Plains Underground Water Conservation District has been tremendously helpful, and we appreciate their advice and input. We really do. They're just tremendous. We've had some federal grants that we've been able to advance these technologies and tools and really study and evaluate things and pay the bills to go tell the story. So I really appreciate that. And any questions, I'll be glad to try to answer them, or I'll defer to them. I'll defer them to somebody in the room who knows more than I do. So I appreciate your time and your invitation. Thank you very much. Uh-oh.
I was going to say, I got
Now
two
I'm
questions, but
scared.
I'm going to give the audience a chance first. Steve?
For the group, can you tell people what fumonisin is?
Fumonisin, thank you. I'm sorry. Fumonisin, there's really it's one of many mycotoxins. When corn or other crops, when they get damaged, it's a fungus, and the toxins can render, if you detect a toxin, fumonisin or aflatoxin is one that you might have heard. When they're detected, they cannot be marketable for human food, dairy feed, or anything. So I get this fungus in a crop. Aflatoxin tends to show up in a drought-stressed crop. Fumonisin tends to show up in wetter conditions. Thank you. I appreciate that. Thanks.
So I got a question on the app asking about
Dirk is picking on me.
the use of produced water for irrigation.
That's a good one. Thank you. Actually, my colleague at Lubbock, Katie Lewis, did her dissertation on produced water for irrigation of cotton, and I get a lot of questions about it. The problem is people read the title of her dissertation and they don't read the fine print. What she did was she mixed, treated produced water, irrigation with it, treated produced water mixed with water from the Pecos Aquifer, salty, and applied straight salty groundwater. And the produced water treatment did better than the groundwater treatment, but that's because she was using treated produced water. So it was, you're looking at, cotton is one of the most salt-tolerant crops that we have. I think only barley is more tolerant, but Vinky said earlier, 5,000 TDS is really high even for cotton. And the risk of accumulating salts in the root zone, particularly where I have a limited irrigation and I'm not leaching, I'm not able to flush the salts below the surface, so I end up accumulating even higher concentrations. So it's very risky. I like the idea, but the treatment necessary is going to make it pretty expensive.
Any other questions from the audience? I do have one more.
Dirk has got me.
I do. It's more common for those of you that see her title, which is pretty extensive up there. I see that she's the extension program leader in her department. And those of us in the room that know about the 4-H2O and 4-H ambassadors, I personally want to say thank you for continuing to support David's program because you're his boss, right? And we appreciate his position in supporting that, and then getting the money goes to the kids. Because most of the money coming, I think, is coming through the groundwater, and we appreciate you for that.
Thank you, Dirk. I really appreciate that. And thanks to David. When he said he was going to start this program, and I was new in this role, and I was thinking, well, he's going to do it for next year. No, he started, boom, right out of the gate, because that's David. Y'all know David. No, I agree. He's doing the Texas 4-H Water Ambassadors program, and the students out there, I got the opportunity to visit with some of them. They're doing a tremendous job. He's doing a tremendous job. But I know a lot of your districts, a lot of your groups are supporting his program, and it It's great. Janet Guthrie and I were talking earlier. You know, if this had been around when we were in high school, our paths to where we got might have been a lot straighter, you know. But thank you, David. Thank you, Dirk. And thank you, everybody who's supporting the program.
Thank you so much.
Thank you.